I'm now going to work through a little problem for the IB program, Maths Middle Years program. What we have here is a salmon who is in a stream, and what he's going to do is he's going to swim upstream 20 meters against the current, and then he's going to swim downstream 45 meters with the current. We know the current is 0.5 meters per second squared, and we know that he takes 70 seconds altogether. So what we want to try and calculate is what is the speed of the salmon through the water, assuming that that speed is constant. So we've just finished our section on quadratic equations and algebraic identities, so you might expect to use those things in your solution. Not necessarily all of them, but some of them. So let's take a look at the problem. We have a little salmon here and he's starting to head upstream. What can we say about his minimum speed through the water? If you take a second to think, he must be going more than 0.5 meters per second, because otherwise it'd be like him sitting in a gymnasium for salmon on a treadmill, pounding away with his fins and not actually going anywhere. So we've given ourselves a limit to what that speed might be. That's going to help later on, as you'll see. So we know that the total time taken, the t-tot we'll call it, because we like symbols, don't we, is going to be equal to the time to go upstream plus the time to go downstream. And we know that that is equal to 70 seconds. So what we need is to work out some value of time to go up, time to go down. We have information. We know the distance for each of these up and down journeys, but we just don't know how fast the salmon is actually swimming through the water. So we can use our little one of our expressions to work out what is happening here. We know that speed is equal to distance divided by time. So our time is going to be equal to our distance divided by our speed. That's our little dividing triangle there. Okay, so let's just do something for this. Let's see, the t up is going to be the distance up, right, which is, 20 meters. Let me just give myself a bit more space to work with. 20 meters to go up, and we know he's going at his salmon speed through the water, but the water's pushing back at 0.5, so that's his speed through the water. On the downward leg, he's got to go for 45 meters, and this time he's still going at salmon speed, but this time the water's helping him because it's pushing him downstream, and we know that that is equal to 70 seconds. So that's the time upstream, that's the time downstream, add the two together and you get the total round trip time. So now what we've got is an expression here with s minus 0.5 and s plus 0.5, which I hope you'll agree looks just like this expression up here. So we can simplify our denominator by writing the expression like that, the a squared plus b squared. So let's just do that. Let's just move that all up. And we're going to put in that new denominator and then multiply through the numerators. So we're going to have 20 times s plus 10 plus 45 times s, all divided by s squared minus 0.25. That's still equal to 70. We can tidy this up, get s on its own. We can now write that 65s minus 12.5 is equal to what is it, 70s squared minus 17.5 by taking this denominator here and multiplying it by 70 up there. And when we tidy that up, we can end up with the expression that 70s squared minus 65s minus 5 is equal to 0. And there we've got our quadratic equation, which we're going to use our quadratic equation solver to work on. We've got a is equal to 70, B is equal to negative 65, C is equal to negative 5. And when you put that into a calculator and you use the expression up here, when you do that with your calculator, you will get two numbers out, because quadratic equations always generate two numbers. And you will find that the possible values for speed are s equals negative 0.071 meters per second, or s is equal to 1 meter per second. And earlier on we decided that the fish must be swimming at least 0.5 meters per second, otherwise it would just go backwards in the water. So we select as our final answer that the fish must be going at 1 meter per second squared, which looks like a nicely prepared answer. So I hope you found that useful. See you in the next video.